Support for the Blueprint podcast comes from the SANS Institute. Are you a new Blue Team member or a SOC analyst looking to make sense of the vast variety of data that you see on a day-to-day basis? Are you working in a SOC that's plagued with alerts that are constantly bothering you with false positives or repetitive action? If so, I know that pain. I remember being an analyst and walking into the SOC and thinking everything was going to be great and then realizing, oh, we have some serious problems here. I've dealt with those problems over the course of my long career, and the results of what I've learned have been summarized in my brand new course, SEC 450 Blue Team Fundamentals. If you're a new SOC analyst looking to get a grapple on all of the network and host data that you interact with, improve your analysis technique, learn how to reverse engineer malicious file types that you commonly see in phishing or downloaded from the internet, or just get rid of those pain points from the average SOC, like repetitive actions, drowning in tickets, alert fatigue, SEC 450 is the class for you. Check this course out at sansurl.com/450. Hope to see you in class.
This is the Blueprint Podcast, bringing you the latest in cyber defense and security operations from top Blue Team leaders. Blueprint is brought to you by the SANS Institute and is hosted by SANS certified instructor John Hubbard. And now, here's your host, John Hubbard.
On today's episode of Blueprint, we talk with SANS instructor, author, and cloud security expert Kyle Dickinson. Stay tuned to learn about the threats your organization faces when moving to the cloud, log sources for detection of cloud-based attacks, and what special considerations your team needs to make whether you use infrastructure as a service, platform as a service, or software as a service cloud applications. On today's episode of the podcast, we have Kyle Dickinson, a person I've become good friends with over the past year or so as we traveled the world teaching cybersecurity and I guess trying to find the best bowl of ramen that we can possibly find, hilariously enough. Although it's not that Very particular true. Topic we're here to talk about today. We can give you a whole rundown of awesome places to buy ramen around the world, but it's Kyle's other expertise that I was interested in bringing him on the podcast for, which is cloud security. So welcome to the podcast, Kyle. Thank you for taking the time out of your day to join us here.
Yeah, thanks, John, for having me. And the old bait and switch, I did think we were talking about ramen. So, I mean, you'll pay me later, I guess.
We'll get you back with that for sure. So to start off, you could walk us through your journey into InfoSec, because it's one of the things I've learned through talking to everyone here. Everyone has kind of a unique way to finding themselves in the specialty that they got to. So if you could let everyone know like what you do now, what brought you to where you are.
Yeah. So, right now I'm a cloud security architect for Coke Business Solutions, which is, we can look at that as like a managed service provider for Coke Industries with the larger operating companies we have, from manufacturing to refining to building products, consumer products. I work with all of the different internal IT teams and security teams to help reduce the amount of risk introduced to our cloud footprint, and then act as a consultant, if you will, amongst the other teams and looking how we can transform the current offerings we have had for our on-premise environment to the cloud. We had a drive to move to the cloud, and it was actually a $1.5 billion transformation for IT to adopt cloud services to get out of using data centers.
So you said the magic words that I hear so often when cloud enters the room, right? To start this off, let's start high level. I know I want to dive into some deep stuff, but at some point in every organization, there's a meeting that's held, and there's some IT executive that whispers those two magical words, digital transformation. And then everything starts to change, right?
Yeah, absolutely.
And from there on, people are like, oh, we're going full steam ahead into the cloud, right? And, that typically brings some challenges and tons of benefits, of course, that come with it. But starting from there, what are the things that you see companies doing, and what kind of issues does that bring along with it in terms of security?
So with what I've seen from an organization perspective and with the other folks that I've interacted with, be it teaching, just chatting at different conferences, or even just on the Twitter sphere, we hear the term lift and shift a lot. And what that's doing is taking your on-premise infrastructure or your existing infrastructure and then shifting it into the cloud, almost like a, copy and paste from on-premise to the cloud. And that's because the cloud has a lot of different characteristics that are associated with it that are very appealing to a enterprise. And with those characteristics, a couple of them that come to mind is, the on-demand self-service, the global accessibility. So if you needed to create a highly available workload from a console, from a service provider, you can have a distributed infrastructure across the globe with a few clicks of a button. Now, where I see some organizations having to kind of bring it back in a little bit is, the on-demand self-service. So if we think about it in the on-prem days, so long ago, so to speak, if you wanted to stand up a web server, you were probably communicating to someone with procurement, server delivery, data center team, networking team. There was probably 4 or 5 steps for you to be able to get that web server. But when we moved to a cloud service provider, specifically something like infrastructure as service, which is your traditional virtual machines, some network security controls that you have the ability to modify, you're able to stand this up on your own potentially. So you have developers that can be the network engineer, the server administrator, the delivery team, and the procurement team possibly. And with the different terminology that we have when we move to the cloud, it can kind of get us in trouble because the service names are, 1, interesting. 2, there's so many acronyms when it comes to the cloud and different ways to slice and dice it. I say when we move to the cloud, these cloud service providers like Azure and AWS, they're builder clouds. They give us all of these different components to create either the most elaborate castle ever or the hottest dumpster fire. And because of the different outcomes we can have, we really need to take a step back and think about, okay, now that we have this infrastructure potentially out on the internet, what do we need to do to secure it? And we've seen it time and time again, in the, most tech blogs, S3 leaks data. Well, it wasn't an S3 bucket that made itself publicly accessible. It could be something as innocent as a misconfiguration. And misconfigurations happen quite a bit in the cloud, unfortunately.
Yeah. What is it that makes it so common? Is it just that it's a new platform that you think and people don't have the proper training or the time to learn how to use it correctly? Because it's not like we often saw people, oops, I left a file share open to the internet at my on-perimeter server. These aren't foreign concepts, but they're done in a different way. So is that maybe where that's coming from?
I would think it's because the overwhelming amount of services that we have available now and understanding the intricacies of how the service is developed. And so when it comes to the different delivery models we have software as a service, platform as a service, and infrastructure as a service. And so to just make things more complicated, a service provider like AWS and Azure and Google Cloud, they can offer those infrastructure as a service and platform as a service and software as a service delivery models. And what's important to understand about those is when we look at a shared responsibility model, which is the framework that tells us who's responsible for what, sometimes understanding, is the service provider responsible for patching the libraries or application that we're running, or is it us that's responsible? And so looking at the shared responsibility model, that really is what's going to help us determine that and just understanding the ins and outs of a cloud service. I would say the most common services that are adopted from the get-go when it comes to the lift and shift are your virtual machine services like AWS EC2 and Azure VM. And that's as traditional as you can get from your on-premise environment. So you have your virtual machine, you have the ability to control ingress and egress through a security group. Or if you wanted to use something like a network ACL, you could do that as well. You can spin up firewalls in the form of a virtual appliance. But I would also say that something that can really bite us is if we don't strategize how we're going to implement security or be able to create asset inventories or deploy our host-based detections or protections that we had on premise into the cloud, our problem can scale that much rapidly. So we let the cats out of the barn, and now great, now we have to go get the cats. But if we didn't have these controls built in from the start, we're almost playing whack-a-mole where you're able to grab one cat and start walking it back to the barn. We see 4 others walk out the barn. You're just like, oh, this is never ending.
We'll be back after a quick break.
If you're enjoying this episode, then you're undoubtedly interested in building the strongest security operations team that you can. For those who want to go even deeper, did you know that SANS has not 1, but 2 courses that cover security operations centers as well? For the leaders, managers, and directors out there, my co-author Mark Orlando and I offer 551, Building and Leading Security Operations Centers. This course covers building your team, your physical and virtual workspace, getting the right data into your tools, and then focusing on security priorities through everyday execution of important security tasks and building the best SOC team possible. For the technical practitioners out there, my course Sec 450, Blue Team Fundamentals, Security Operations and Analysis is designed to cover everything you need to jump in being the best SOC analyst that you can be. We cover important data types, SOC tools, security logs, malware, analysis technique, automation, and much, much more. In addition, if you want to prove you can deliver the best on any security team, both courses have an accompanying certification available from GIAC. That's the GSOM for 551 and the GSOC for 450. Check out both courses and free demos available on the SANS website. You can get registered today for an in-person course at one of our many events, or go to On Demand and take either class anywhere at your own pace. Thanks for listening. So is it, with those different styles of platforms, IaaS and PaaS and software as a service type stuff, do they start with relatively open defaults in ways that it makes it maybe too easy for people to get into trouble, such that maybe that's part of what needs to change, do you think? Or is that is that the nature of the problem?
It would be, so one of the things that it comes to mind, and one of the common misconfigurations I see is a security group permitting access from the entire internet to a resource. And so there's different ways we can connect to a cloud environment, and that can be over a VPN, Direct Connect, or Express Route, which are dedicated connections from our on-premise environment to a cloud service provider using like the information superhighway known as the internet, but it's a private link using a cloud broker. But also, by default, out of the box, if you and I were to spin up a account or subscription and stand up a virtual machine, it is out on the internet. Like, that's the out-of-box configuration. It's out on the internet, and the only thing that's controlling the ins and or what can come in and what can go out is a security group. And if we don't know what our IP address is for where we're trying to connect to this virtual machine from, what's the path of least resistance? Allowing it all.
What could go wrong?
And we've all heard that story of, I'm going to allow it all just temporarily. And then, a week later, you're like, yeah, why is this port sweeping a bunch of stuff now? It's like, I forgot to change this temporary configuration that I had in place. Or it's, when temporary becomes a production load.
Mm-hmm. Yep.
And so that's, the service providers help us out as much as they can by flashing warnings of, hey, this is allowing the entire internet access to your resources. And taking it back to, S3, which poor little guy got such a bad rap. It didn't make itself public. It was just accidental misconfigurations. And they took strides in making it so you could see what is public. And then when people were accidentally configuring public S3 buckets again, they said, all right, we're going to put in this logical, break the glass before you can make the S3 bucket public. And that came in the form of the block public access, which is now a configuration item. So you have to uncheck the box before it can be made public. So it's like the big cover over the big red button. And I've never met a big red button that I did not want to press. So
AWS is trying to help us, but yet through all of that, we're still somehow finding a way to skirt the controls. And yeah. So I know we have a lot of S3 related, or just I left something public related, as a file style compromise or attacks. What other type of threat models or attack surfaces created by using these services that maybe people aren't as aware of and often gets them into trouble?
Yeah. So one of the great things about these service providers is I mentioned platform as a service, and that takes the administration of underlying infrastructure for applications like SQL or Postgres or big data analytics tools away from the end user. So you're just being able to benefit from the tools itself. And so, you and I have stood up SQL databases. Managing that underlying virtual machine isn't really something that we want to do. We want to get off the ground running and do cool stuff.
Right.
And that's where platform as a service comes into play. But what can happen is a library could be out of date. These are still applications that are used throughout the market that could potentially have vulnerabilities associated with them. Mm-hmm. One of them that comes to mind, so a service provider has a big data service, and one of the components that they leverage was susceptible to remote code execution. And again, the only way that this attack could work is if the port was allowed to receive connections from the internet. Now, as the tale goes, sometimes the path of least resistance or, security is being a barrier to innovation. We hear that a lot, right? If it were to accidentally, and I use accidentally with air quotes, were to be exposed to the internet, there's scripts out there that will allow you to attack this big data analytics functionality and then potentially do remote kit execution. And what's unique about that, when we come to cloud service providers, thinking about AWS for the moment, is we can then use the underlying EC2 instances as potential pivot points to perform actions within the account itself that it's in, depending on how that instance is configured. And if it has what they call an instance profile attached, which then essentially gives that resource the ability to perform actions within the account. Now, that is common. However, if we don't practice least privilege access, that's where we could really find ourselves in trouble.
So if you get access to one of these instances, it becomes like a lateral movement thing, not just within the other virtual machines, but into the actual AWS account itself. And you're seeing actions being taken at that level, just from access to a singular machine in the account.
Yeah. And, the stars have to align for that to occur or happen. But more times than not, you're going to find a role in a lot of production environments that should be scoped to specific resources, because if we want, as part of our workload that we have and the different components that we've used to create this workload, we want this virtual machine to be able to interact with the other components without having to necessarily pivot out to the internet and then back to the service provider. Mm-hmm. It can execute these commands, and that's a preferred way for it to be able to interact with services such as a storage service or manipulate other resources. However, if it's too permissive, we could find ourselves into trouble. It actually reminds me of a time where I was talking to someone at a conference, and they mentioned, we have this fancy mechanism that looks at the policies that are in place and attached to roles, which allow someone to, that's your authorization piece within AWS. So we have this super duper awesome automation, and it'll look at the policies that are attached to these roles. And if they have what we'll consider restricted actions, be it sensitive actions to modify networking attributes or potentially increase a blast radius, then they'll revoke those API calls. But what they did not take into consideration was instance profiles and EC2 roles. And they found that a developer had attached a role to an EC2 instance with administration access. And then they were just using that EC2 instance as almost like a bastion user in a way. So bypassing the technical control they had and the process that they had in place by leveraging a different type of role on an EC2 instance. And I thought that was pretty clever, but then it made me realize maybe I should look at my own environment. Fortunately, I work with a lot of folks that practice strong integrity, so didn't come across that.
That's good. The thing I'm thinking as you're describing this is, as the blue team, right, we have to assume that people are going to make these errors because we know it's happening. We know it's going to happen. People aren't going to be perfect about it. So given the types of attacks you talked about, you leave the resource open to the whole internet, right? There's got to be some kind of log that's created that tells you that the whole internet is accessing your services, or that someone has taken a profile from one instance and is using it to spin up other instances or other various things like that. For each of these types of platforms, what are the main data sources that a blue team should be asking anyone that's, spinning these things up? What do we have this so that you can detect those sorts of attacks?
Right. So that's an awesome question. The folks that I've spoken to in the past, there's been a common misconception that I've heard of. It's in the cloud, so it's being logged for us. No, we still need to have a logging strategy in place. And when we move to cloud service providers, again, it depends on, are we using infrastructure, platform, or software as a service? With infrastructure as a service, we could build in our logging strategy almost similar to what we have on premise. We may lose some visibility when it comes to network flow. We're not going to be able to, ship the service provider our favorite network tap device that we have and say, hey, can you go and just put that in one of your racks for us, plug it on in and let us know when it's good to go? No, we don't get that. We will have to strategize a little bit better.
However, AWS did change that a little bit recently, didn't they?
A little bit. So AWS Nitro, which was a hypervisor that they built in-house, extends to what they call traffic mirroring. And that's available for AWS Nitro instances, starting at T3. And, there's a long list of the different sizes of instances and types of instances. But to boil it down, Nitro instances, you can configure traffic mirroring, but it's just that. We're not putting like an IPS in line to be able to prevent communications unless we were using like a host-based IPS. Mm-hmm. Something about traffic mirroring as well is that you do need to set it up per EC2 instance that you want to mirror.
Right.
But the targets can be either a, security onion or a Windows server, and you just fire open Wireshark. But then there's vendors that are creating these virtual appliances that can be targets for the traffic mirroring session. And then it'll bring it into like a comprehensive view. So you have, the network intelligence, so if you look at the common network monitoring tools, they may offer something that integrates with traffic mirroring.
Sure. So yeah, for infrastructure as a service, Blue Teams can, if I'm getting this correctly, basically think about it like anything that's on-prem, and that they can put a logging agent on it. They can collect the logs. In some cases, they can go for the network traffic, but it is a full computer under their control. And so they can collect logs in a lot of ways. Yeah. But platform as a service and software as a service, different game, right?
Yeah.
How do we deal with that?
So looking at the opposite side of the spectrum from infrastructure, we have software as a service. And really that's, we're at the mercy of what the service provider is going to provide us when it comes to the SASE logs. And with these logs, with SaaS providers, they most likely have an API that they'll extend to us to leverage to either make it part of an application fabric or to interact with the service. And that's how we're going to be obtaining these logs. However, I will say that with larger environments, I like to say I'm the CEO of API throttle exceptions. I haven't met an API where I've been tar pitted, but we need to look at how can we get those logs out. And so with, as an example, Microsoft 365, they offer the O365 Management API, where we can query the API to obtain these logs from the different services that they have. And then they have Azure AD for Office 365 specific logs. And then we can look at like service health notifications, things of that nature. Mm-hmm. But again, we have no control over, what logs Microsoft's going to provide us. And that's not a dig. It's just something we need to come to grips with and understand what logs. So when we're doing our evaluations of the different service providers, understanding what logging we have available to us, and aside from just activity logs of an application, do we have some sort of audit logs available to us at the, the administrative console, so to speak. So ultimately, it kind of boils down to 5 different log sources that we want to look at. And this is something we drive home, especially in Sec 488. So we want to look at cloud management plain logs, be it your administrative console for a SaaS provider or your AWS console, Azure console, Google Cloud. John turned on this virtual machine on this date from this source IP using Netscape Communicator. Mm-hmm. We have service-specific logs. Now, some of the services, and this is why we want to understand the components that we have, some of the services may log to an existing log source by default. Others might not. So you may need to enable those logs after you've deployed the service. And an example of that could be Azure Key Vault. So if you wanted to understand, did Mark use a key or did he rotate a secret, you would need to enable that service-specific logging. But from the cloud management plane logging, we could see that John created a key vault. And then very similar to on-premise, we have the host and application logs. And then with our storage services, we have logging available there as well. And then, similar to on-premise, we have our vulnerability scanners, our ITOM management that we may be using, flow logs, the other miscellaneous logs. And this, you're going to be doing a lot of enrichment, but this is how you could provide a full picture of a environment.
So yeah, between those 5, it seems like that would cover everything that you talked about, right? So if I'm writing these down as you said them, cloud management plane, that's going to cover someone's creating something because they hacked in, they got control of something that allowed them to make a new resource that shouldn't have existed in the first place, right?
Yeah.
Service specific logs, turning on for any kind of, there's a whole bunch of stuff that could cover, right? Anything that's acting out of the ordinary, anomalous or otherwise. Host and application logs, if someone's running a process, they've got control of an instance, we can pick it up with any kind of, system monitoring, application access logs or whatever. Storage services cover is the whole internet getting into your S3 bucket thing, right?
Yeah. Who's doing what with my data?
Yeah.
Either it be the internet or, an internal resource.
That one seems like it would be really easy. If you could just write a rule that's just is anyone logging in that's not our IP?
Yeah.
That one seems like it would be fairly straightforward. So blue team's out there. There you go.
Yeah. And, to kind of pair it to service names for the different domains of the logging, we'll call them domains because it's you and I talking. So for cloud management plane logs, for AWS, it's CloudTrail. For Azure, it's Azure Activity Logs. For service-specific logs, it has changed names a couple times from what I've witnessed. It's been like diagnostic logging for the different Azure services. It might be something different. And that's not a dig. It's just if you go to look at that service and you don't see diagnostic logging, there's probably a log service associated with that service where you'd be sending it to something like an event hub. You then send to either a storage account like a Azure Storage Blob, which is similar to S3, or directly to like your SIM or logging tool. And then with the server-specific logs within AWS, for instance, the big data service that I was talking about, AWS EMR, Elastic MapReduce, it stands up an S3 bucket, or you can send the logs to an existing S3 bucket, and it logs the different actions that are performed within that EMR cluster. And so looking at the service itself, does it create its own log stream to either an S3 bucket or CloudWatch log group, or does it integrate with CloudTrail? And so services that will send logs to CloudTrail are like AWS Lambda, which is the serverless or functions as a service within AWS. Key management service, KMS, sends to CloudTrail as well. And then S3 for the object level logging, such as, who put this file in this S3 bucket, that'll send to CloudTrail as well. And so the different services will have different ways it logs. And so this is why when we're looking at the components, we got to do our due diligence and say, hey, you know what? How can we get visibility into this thing? Because it may change.
Sure. And then the vulnerability scanner logs of sorts, that covers kind of that last piece where you're saying sometimes there's a library in there that may be out of date, that the cloud service provider, because of the shared responsibility model, they're the ones changing it. You can't change it. So as a blue team, you can really just be aware that it's there.
Yeah, you could be aware of the risk.
Take other steps, right?
Yeah, and if you're aware of the risk, understand, it's that whole looking at risk and how you evaluate it. What's the likelihood of it being leveraged to exploit a system, and what's the impact? And if we see, okay, it's using a vulnerable library, but the way to attack it is to have this port exposed to the internet, we may then want to generate an alert or content surrounding, okay, well, if this security group allows this port to the internet, we should have some automation to either, undo it or send the SOC an alert to brace for impact.
Yeah.
For in case if an event does happen. It's fun. Cloud is easy.
One of the other things you had brought up that I wanted to dig into a little bit, because I think it's, on the horizon a little bit more so, but becoming very, very popular quickly as well, is serverless. How is that different than the other things we've talked about? Is there any additional attack surface there? And how do you log what's going on with your functions in AWS Lambda? And what would an attack even look like for that sort of thing? Because I almost hear about no attacks leveraging that yet. And maybe it's because they're not happening. Maybe I'm not reading the right stuff. But what do we need to watch out for there?
So I think the first step that we would need to do is just come to the acceptance of, if something were to trigger an alert, and we determine that it is using the Lambda service or the Azure function service, we're not going to be able to do our traditional forensics or investigation because there's a likelihood that that resource is no longer there.
Mm-hmm.
Now, as far as, attacks to the cloud, I have not seen yet, knock on wood, but unfortunately I have a glass desk in front of me, so I'm going to be reading about something in a week. I haven't seen serverless or functions as a service being a huge attack surface yet.
Mm-hmm.
But I'm sure as the different, organizations and industries start to refactor their applications from the traditional lift and shift using virtual machines to something that's more robust and scalable to using, containers and serverless technologies, those types of attacks will increase. For us to be able to gain an insight to the vulnerabilities within our different, functions that we have out there, this is where we start talking about the DevOps lifecycle and building in different security controls throughout the development lifecycle, such as when a developer is creating code and checks it in, we have something that's scanning for vulnerable libraries, or secrets that are in plain text. And it starts to become this holistic methodology where we want to strive to secure it before it's out in production and running. There's a bunch of different tools out there that will look at the libraries and scan for entropy for secrets and the like. And then for containers, because containers are gaining popularity as well.
Oh, yeah.
Yeah, especially when it comes to workloads that we want to scale to absorb a lot of requests and then scale back down. Those, they have runtime execution protections, or you can install some sort of detection agent on the host that's running the containers. But if you're using something such as like AWS Fargate, they are running the infrastructure for you. You tell the containers how to run, and that's about it. You don't have that access to the underlying infrastructure that's running it. And so how can we secure that? Well, we can build in some sort of vulnerability scanning in our build process, or take advantage of the different image scanning that the service offers. So with AWS's Elastic Container Service, if you push an image to it, we can configure it to do a vulnerability scan. And it uses CoreOS's Claire and looks for CVEs associated with the libraries you're leveraging. And same with Azure, they have a scanner that's leveraging Qualys's technology to scan the container image you're using as well.
Oh, nice.
And so it's becoming more of a popular, I would say it's always been an issue, but I would say that as new services come out and enterprises are starting to leverage these services more and more, I'm sure we'll be seeing more and more attacks, but why try to create a sophisticated attack when we can look for a publicly accessible storage account or bucket or a EC2 instance that's overly permissive and has default credentials?
Yep. Lowest hanging fruit, right?
Yeah.
So when something does go wrong in an AWS environment, you're not showing up at Amazon and asking for the hard drive. What is forensics going to look like for if you have an EC2 instance or just maybe even a platform as a service kind of thing where there's a compromise? What is available to defense teams in that situation?
It's whatever you've had set up prior to the incident. So, and I say this kind of jokingly, but also sometimes you're like, oh, well, didn't think of that. So let's put it in perspective. So AWS CloudTrail, a couple of years ago, it had up to 7 days of activity within the console itself. And it was only like it was a rolling 7 days. So if something were to happen and then you were to detect it 30 days later, you wouldn't have had that information unless if you have configured what they call a trail. And that trail is the configuration piece to where are you going to send the logs for storage. And then from there, you can set up an ingestion point for your SIM or logging tool to then bring those logs out of the account. And so now, again, AWS being good stewards, not just AWS, but Azure as well. All the service providers are wanting to be good stewards to its consumers to make cloud less difficult and harder to introduce risk accidentally. And so now by default, we have 90 days of activity logs or CloudTrail logs within a AWS account. Now, if we don't have those sending to a trail, we're not going to be potentially alerting to like our SIM that we have, but we still have, a 90-day recording of what has happened. So we can leverage those logs. However, as you mentioned, we're not going to be able to walk up to, the service provider and say, hey, can you give us the hard drive, please? We'll be back with it in a day or two, unfortunately. However, there's a methodology and actually a pretty cool white paper in the SANS reading room by someone I'm very close with that speaks about the whole incident response process when it comes to the cloud and things we need to consider, such as, how does the cloud change? What services are we using? Is it infrastructure, platform, or software? And it covers that whole gamut. But taking a easy scenario, we're going to take the easy road here. If it was a virtual machine that had a compromise and that virtual machine is still up and running, we can do memory forensics. So we can grab the memory from it if we wanted to, assuming we have access to that virtual machine. We can take a snapshot of the volume that's attached to that virtual machine and then restore that snapshot as a volume to a, say, SANS SIFT forensic workstation. There's also folks that have even created automations to do this for us. Andrew Krug, he created this tool called SSM Acquire that uses the AWS System Manager agent to capture a forensic image for us And then there's also the AWS IR CLI, which will automate memory acquisition and image capturing and actually quarantining of a compromised EC2 instance for us.
Nice.
Yeah.
Is there a list of like those tools that we can put them in the show notes for sure, but is there any like good list of resources for all those kind of things that are out there?
A good friend of mine, Tony De La Fuente, aka Tony Blix, he wrote a tool called Prowler. He maintains a very large list of all the different AWS security tools, and SANS even has a other curated list of tools that instructors have created that are open source as well and revolve around cloud security too. Yeah, I'll get you those links and we can go ahead and share them out. But there's so many awesome open source projects out there now to help us enable incident response and forensics and, overall security compliance when it comes to the cloud.
So one of the things that I picked up on that I think stuck out most to me, whatever you set up prior to the incident, as you put it, right? That might be one of the key, maybe we should title the episode that, right? Cloud security, whatever you set up prior to the incident.
Yeah.
This is obviously something that if people don't know, they're not going to have it in place, right? So one of the big things that you've contributed to recently is a brand new class on this topic, Sec 488, you had mentioned earlier. Can you tell us a little bit about that class and what's in it and how this all kind of ties into that?
Yeah, so Sec 488 is going to be the most epic week ever. And we cover the essentials of how to, the different security components we have within the different service providers, because we understand that enterprise may not use only one service provider. They may be using a multi-cloud strategy. And that is something that's becoming more and more popular for different reasons, because it, varies based on the use cases and requirements that a company will have. And we'll go over the different services of how we can secure our virtual machines, how we can strategize the overall vulnerability management, our logging, identity and access management. And I throw in a lot of funny stories because, I wasn't always a cloud security person. I've always had security in the back of my mind, but I became fascinated with security when I was on AOL 4.0. My printer started printing weird stuff. And then I got this IM from someone that I used to play StarCraft with saying, did it print? And I'm like, how did you do that? And then I was hooked. But I also advocate that I've done a lot of goofy things. So I want to share those experiences of things that, I will humbly admit I've made mistakes. And here's how you can avoid these mistakes. Ultimately, we want to cover, if we don't strategize, what can we do to help bring back sanity to the security realm when we have all these different locations of where resources are? If you thought that remediating a server that doesn't have your antivirus installed on it was hard on premise, now imagine if you're in an environment where you don't have any central connectivity to the virtual machines that are out running in your environment. You basically now have 100 different data centers. Or if you're working in larger environments and have 500 to 1,000 accounts, the strategy starts to become challenging and time consuming. So I help you navigate what we should look out for to, one, reduce the amount of risk introduced during your movement to the cloud, be it lift and shift, or looking at brand new services altogether. And what are the different nuances that I've personally ran into with the different service providers, how we can go about incident response, vulnerability assessments, maybe even pen testing our environment. Yeah, I'll give a shout out to the red teamers. I'm a blue teamer at heart, but hey, someone has to kick the sandcastle, right?
Yep. Awesome. Sounds like a great class. Where can we find information, contact you online? Do you have any Twitter handles, not any other things you want to shout out so we can follow what you're doing going forward?
Yeah, absolutely. So, and I actually mentioned this to all the folks that I interact with and, folks that I've taught. I'm always open for questions. It doesn't matter now. It doesn't mean I have a 24-hour SLA, but I'm certainly open for questions. On Twitter, I'm Kyle Haxwy, Haxwhy. Don't ask, because I really had no creativity when I was creating that Twitter handle. Actually, I was a Nickelodeon kid growing up, and I always liked the show Kyle XY. And I was like, that's a play on words. I am witty. My SANS instructor bio, sans.org/instructor/Kyle-Dickinson, has, all the different white papers I've created, including that how to do an investigation in AWS, but then also looking at how third-party tools like a cloud access security broker can help you rein in, data loss prevention and provide additional context and insight to your environment. And then also another white paper on how to look at cloud security posture management platforms, which would be your continuous compliance, your misconfiguration detection tool, so to speak, at scale. Our service providers do offer the services we have, but with multi-cloud strategies, you may find that a requirement is that you use a third-party vendor. And so we cover how to evaluate the different platforms we have out there, depending on your use case and requirements, and how to deploy that at scale. And you'll notice I use the term at scale a lot because I have witnessed more times than not, you may start with one account or two accounts, production or non-production account. And then the next week you may have 15. And then you're like, maybe I should have created that golden image for everyone to use. And then you grow to 100 and then 400. And so really, how do we address security at scale as well? And I also advocate making friends with developers. And now I know a lot of people may have just choked on food or dropped their water or whatever they're doing right now. But this is a great opportunity for security to become, a bodyguard versus a bouncer. So I mentioned, you could build the most elaborate castle or dumpster fire with being a bouncer instead of saying yes or no and yes or no, and not being invited to the barbecue in the future, becoming a bodyguard where we create these different guardrails and controls based on automations, additional insight, feedback loops. This is stuff we cover in 488 as well. But if the developer is going to go pick a fight with the biggest person in the room, we go ahead and prevent them from doing that, introducing risk into their life and showing them a different path of, where to go or what to do instead.
That's a great analogy. I like that one.
Yeah, bouncer to bodyguard.
All right. Well, with that, thank you for coming on the podcast. And we'll make sure we get the link to all your white papers and Twitter and class information for Sec 488 and look forward to seeing all the stuff you're doing in the future. So thanks for joining us on the Blueprint podcast, and we will catch you later.
Yeah, thanks for having me. Y'all take care.
Hey, Blue Teamers. I hope you enjoyed today's episode of Blueprint. If you've got a second and want to help support the podcast, please subscribe and leave us a review on Apple Podcasts. It would be really, really meaningful to us. And if you have any ideas or suggestions, I would love to hear them. Your reviews are going to be one of the best ways to help others find this podcast. So anything you could do would be a big help. As always, thank you for listening. You can connect to me on social at SecHub, SecHubb on Twitter or on LinkedIn. So until next time, thank you for listening to the Blueprint Podcast.